Welcome to the first video of the series of Turning AI Gears Your Way, the introduction to artificial intelligence. I am the Tech Emissary, literally, as seen through my YouTube username, and I'll be bringing you on a journey to understand more about AI through theories and practicals that I'll demonstrate throughout this series. My goal is for you to be able to bring back something to be used in your own ventures in AI, whether it be for industrial, hobby, or course learning purposes. I will talk more about the logistics, along with my motivation of doing this series at the end of the video. But first, let's get our heads into the overall concept of artificial intelligence first. There are a variety of definitions that are available for AI. I would like to take just 3 examples of them, each from well-known sources. Merriam-Webster's definition is that it is a branch of computer science dealing with the simulation of intelligent behavior in computers. Pay attention to the usage of the word intelligent here, as I've made the word bold on purpose, in this example and the other examples. Many have said that the definitions that I've attempted to define intelligent are controversial. No one can agree on one specific condition. However, we will try to find an accepted definition for it in this context anyway. One of these definitions is from an op-ed in Wall Street Journal, which says that it is a very general mental capability that, among other things, involves the ability to reason, plan, solve problems, think abstractly, comprehend complex ideas, learn quickly, and learn from experience. It is not merely book learning, a narrow academic skill, or test-taking smarts. Rather, it reflects a broader and deeper capability for comprehending our surroundings, catching on, making sense of things, or figuring out what to do. So, we're able to see that it is kind of behavior that encourages human-like nature, which is the whole essence of artificial intelligence after all. Another definition of artificial intelligence is from one of the fathers of artificial intelligence himself, John McCarthy. So just a bit aside of him, he was crazy smart, graduated from his high school, Belmont High School, 2 years early, and eventually skipped his first 2 years of mathematics at Caltech, and eventually earned a Bachelor of Sciences in mathematics there, although he was suspended for failing to attend physical education classes for a period of time, and eventually he went to Princeton for his PhD. He eventually coined the term artificial intelligence in 1955, eventually becoming one of the founding fathers of artificial intelligence, along with Marvin Minsky, Alan Newell, and Herbert A. Simon. Eventually, one of his well-known ventures into AI is the Advice Taker, a program that could quote-unquote use common sense, which would later help a lot with the evolving of logic programming on AI. And finally, we come to the definition of Friendly Goobel in his research at Oxford, which is the study and design of intelligent agents or rational agents, where an intelligent agent is a system that perceives its environment and takes actions which maximizes its chance of success. His definition of it is that it is the science and engineering of making intelligent machines. Note that the use of intelligent agents here, as it is crucial to the understanding of AI, as these agents are mimicking human behavior, our behavior, in order for them to accomplish what they have been made specifically to do, and take the action which would most likely let them reach the best outcome. And this can be in the form of example of simple true and false statements to the more complex algorithms such as those involving decision trees. We'll talk more about it again later as we make our way through the series. Now I must put one special section for discussion in Alan Turing, because he's one of the most prominent roots to the whole concept of AI. Some of you may have seen the Imitation Games movie, as seen on the picture on the top right, played by Benedict Cumberbatch very nicely. So you may more or less know the history, how the history goes, and his contributions, or you may have just known his contributions throughout his papers. Really great moment in Imitation Game movie I remember was when Cumberbatch as Turing, when he was interrogated by an officer, he asked the officer, "Am I a machine? Am I human? Am I a war hero? Or am I a criminal?" And also the quote, "Of course, machines can't think as people do. A machine is different from a person, hence they think differently." The interesting question is, just because something thinks differently from you, does that mean it's not thinking? So this really outlines his real-world experiment of whether he can prove a machine's intelligence by asking someone to ask a series of questions to an artificial entity and a human, both not known as to which is which by him or her, and if the person fails to distinguish which is the machine and which is the human, that proves that the machine can indeed be called intelligent. On the other hand, his electromechanical machine to crack Enigma, Bomb, was also one of the first inspirations for intelligent machines, especially since it was able to perform a search over the many permutations in order to eventually find the correct set to solve the codes that German used. So this was really a great breakthrough in the field of AI, though it may now be considered simple in the midst of the even more complicated AI applications already in the field. Now I'll stop the history section there, as I want this series to be more based on theories and practicals of implementation, as history can easily be searched and found elsewhere. Now, I'll briefly mention the four schools of thought for AI. First is thinking humanly, second is acting humanly, third is thinking rationally, fourth is acting rationally. In thinking humanly, this related to Turing's question as to whether a machine can be intelligent or think as like a human, if you will. This is where AI connects with cognitive science as it studies how humans think. Similarly, AI has to mimic this behavior. Acting humanly is another big factor, as they would have to be able to conceal their identity as a robot, and if possible, try to act as a human would. Most machines that we often come across talk in a very robotic manner, such as most text-to-speech processing software, so this is another area in which a lot of people are working on to improve eventually. Turing's test on intelligence resembles this very clearly. In thinking rationally, we want to be able to see success in how the AI can reason based on the situations given to it, and eventually this connects with the fourth school of thought, acting rationally, to see if it is able to act based on the best decision that is available to it, so that it may also be a part of logic-based programming. Just a bit on logic. We are going to go over this a lot in the series, but it is important to note that as important as it is, there is also an extent to how much it can be useful. You may be familiar with statements such as not, and, or, if then, if and only if, or groupings. These all helps many algorithms to find a decision take based on the situations presented to it. But what if something requires more than just logic? We'll also look at that later in the series. Now, I'm going to briefly discuss some applications of AI in the field. Even if I did not discuss it, you'd probably already see some of these applications around the field. Even you may be using some of them, although you may not be aware of it. Firstly, I'd like to discuss regarding military applications. This has been recently developing very rapidly, especially with the development of drones. Now, most drones can also self-control themselves. So, we no longer need humans to control the drones, to be able to monitor different areas. They can also operate by themselves without the humans controlling them. So it's really interesting area of research as well. Hospitals. We've been seeing a lot of development in hospitals as well, such as now there are virtual assistants in hospitals for people to communicate with and ask for prescriptions and to pass messages to, etc. So people no longer have to go to doctors every time they want something. They can just perhaps ask the AI, and the AI can pass on the message to the doctor, or perhaps the patients can ask the AI something as well that the AI has been already programmed to do and is meant to do. So it's a very interesting area of research as well. Finance is another big area, especially since now there are robo-advice. And when I say robo-advice, this is because people want to decrease their funding to, for example, brokers or financial advisors. Now, AI is able to detect the performance of the market. They are able to survey what's going on in the market, or they can also check, for example, your portfolio or other performances that you input into the system. And they can make advices based on those kinds of data that you put into the system. So it's very interesting to try to implement. And also, we can see that this can save a lot of cost for many people, all in all. Video games is something that has been developing rapidly, and we have already seen it actually from a long time ago. We have seen it since we first started playing chess AI, for example, because when we start playing chess, there's always an AI that is always against us, right? Eventually, from simple AI such as that, it eventually evolved to the more complex ones, such as the AI for, let's say, the first person shooter games, such as Call of Duty. We're able to see them program pathways and also to help them get other functions to, for example, to call us or many other different kinds of situations that they can detect and move along their own. So that's another interesting area of research as well. It's very interesting to see how video games are developing at this time. Next one is transportation. And of course, many of you, of course, have heard of the Google car, which is known as the self-driving car, as you can see on the second picture in the slide. It's a very interesting area of research because just think of the possibilities when we have an automated world. We can really decrease the amount of drivers. We may even not need driver licenses anymore. But of course, this raises a lot of issues as to how we will do that shift. What are the legal issues with shifting without driver licenses? And so that's quite a potential area that has still a lot of potential, but there are also lots of legal concerns as well there. So I suppose that we'll be able to see much more developments in the future. Finally, music. Now, this area of research has recently been really interesting for me because I have seen a lot of new things that I thought I wouldn't see previously, including now AI making their own music. In fact, recently on the news, a music album called I Am AI was released, which was entirely composed and produced by an artificial intelligence, which is crazy because when we think about it, shouldn't music composition only be available for humans to compose? No, it turns out that AI can also do it. So it's really interesting to see how these progressions are progressing. And as more research is done into these areas, I'm sure that more efficient methods of being able to execute these kinds of production purposes and many other implementation areas can be done. And for example, such as music, perhaps now the music may not exactly be as smooth or as popular as the usual music these days, but as research progresses, AI will probably be able to detect more soothing patterns for people, as I may say it, or more popular patterns that people are currently enjoying, the trends in music people are enjoying. So it still holds a lot of potential improvement. So that's something to look forward to as well. So in regards to my own motivation for making this series, I actually started really liking AI after I started watching the films related to AI, such as Terminator or HAL, which is why I put Arnold Schwarzenegger on the picture of the slide here. You can see over there with his iconic quote, "I'll be back." But that was where it all started for me. I really started to think of new ideas because of that. And it just shows that we haven't really managed to realize the full potential of AI yet. Because many people say that from such movies such as Terminator, AI could actually be the end of the world. They could create the end of the world for us because one day maybe humans cannot control them. But on a positive side, there is still so much potential that means for us. That's why I really want this course to be able to be beneficial for those who watch it in order for them to be able to implement it in their own areas so that the innovation in AI keeps going on. And I do look forward to seeing that happen over time. So this series is basically going to be based on real world projects, and there will be theories that will build up to the eventual building and execution of the so-called real world projects. So I'll be going over theories, then after that there will be a project, then after that theories again, then after a project, and so on and so on. So basically that's going to be how it's going to go. So because I want you to be able to take something and apply it to the real world. I don't want you to walk away with just theories and not be able to contribute anything with that. So that's what I want you to do eventually in watching this series. And I want you to be able to do that along the way. So you don't have to wait until you finish the whole series. I want you to be able to keep taking in new knowledge and eventually implementing it onto your real world applications that way. So since AI is, people may say, a complex topic, this is going to be a bumpy journey. There are going to be a lot of theories that may require fundamentals learned first, prerequisites learned, for example, like linear algebra or calculus 2 or even 3. But what I want you to have is lots of fun. Don't let prerequisites limit you. Don't be scared of people saying, oh, it's calculus 3 or linear algebra. That's going to be a long path. No. I want you to be able to enjoy what we are taking from here. And I want you to be able to enjoy the learning that we're going to do. Because AI is supposed to be a fun field. So I would say that other than the prerequisites that may be required for this course, I'm not going to mention it because it's going to be based on multiple kinds of mathematics. I'm going to be basing this on also that the fact that you all have fun and you all are enthusiastic regarding learning about AI. And I shouldn't say this as a course. It's more of a series because I don't want this to be formal. I want this to be a discussion between you and me. So I believe that just want the series to be able to be beneficial for you. And you can also learn alongside the series with the prerequisites that I mentioned before. For example, if you want to brush up on some mathematics that I may use, that are required for the mathematics that I use. But aside from that, I just wish you to have a great learning experience from my series, and I want you to have fun while learning. So we'll start talking more about AI in the next video of this series, and I will see you there. Thank you.